All right, hi guys, we're starting a new chapter here now, and it's trigonometry. You did a little bit of this back in um, geometry, and you'll do more of this next year, obviously. So hopefully you remember some of this. Some of this is going to be new. But the first thing we're going to talk about, maybe you heard something about a famous mathematical princess, but it was just a way to help you remember sine, cosine, and tangent, and it's SOHCAHTOA. I always like to write it like this because it's going to be fractions. The letters are very important with what goes where, so be careful copying these. What these stand for is this sign right there, and it stands for opposite, or it means the opposite side over the hypotenuse side. And we get that from this triangle over here. So what we're going to do is we're going to label an angle, and notice we're being fancy here and we're calling angles theta. That's just a Greek letter. So I'm going to put it down here. We're always going to put our angle kind of right here. You'll see we'll do more with this, and this will be the origin. So that'll always be our 0, 0 when we start graphing. But just put the theta sign right there. This slanted side across from the right angle is the hypotenuse. I'm just going to put that for short. We refer to the angle. So this side is the side that's opposite from the angle. So this is our opposite side. And then this side right here is touching the angle, so that's the adjacent side. That's what adjacent means, it's right next to it. All right, so then sine just means the opposite side over the hypotenuse. Cosine is the adjacent side over the hypotenuse. And tangent would be the opposite side over the adjacent. So we're just going to set up these fractions, these ratios with this. Now, these probably look new to you. Maybe you've seen them, maybe you haven't, but these are just reciprocals of the sine, cosine, and tangent. So this one's called cosecant. That stands for cosecant. And this is really 1 over sine. Or just flip this fraction. It's really the hypotenuse over the opposite. The next one is secant, and that is the reciprocal of cosine. So it's 1 over cosine, or we could say it's the hypotenuse over the adjacent. And then cotangent is 1 over tangent, or we would just say the adjacent over the opposite. So we're just going to take these ratios from SOHCAHTOA and we're going to flip them. All right, now I just want to kind of point things out because these are new and they're kind of weird sounding, I think anyway. So if you look here, tangent and cotangent. You actually say the word tangent if you say this whole word, but they both have a T in it. So I kind of use that to help me remember. For the these two, I feel like these get mixed up. So here's what I do to try to remember this, because they both have C's, they both have S's. If you look here, cosine starts with a C and ends with an S, and secant ends with a C and starts with an S. It's almost like they flip those letters. The middle letter is a different vowel, but honestly, that's what I do to try to remember which is which, because they do get confusing. All right, so again, part of this is going to be stuff you did in geometry, and then part of this will be new. Let's go ahead and try one. So I'm giving you one trig function here. We need to find the other 5. So what we're going to do is we're going to draw a right triangle here. And there's my right triangle. So again, this is my hypotenuse right here. You want to put an H there so you know. We're going to call this theta. I always like to put the angle down here at the bottom here because that's where it's going to be throughout the whole chapter. So then this is my opposite side and this is my adjacent side. It kind of helps to have those labeled. So what's given to us is sine. Sine means opposite over hypotenuse. So this opposite side is going to be labeled with a 5. Sorry, I just said that wrong. The 13 is the hypotenuse. So sorry about that. So I've got the opposite over the hypotenuse. I'm going to put a 5 over here where that opposite side is. And I'm going to put a 13 where the hypotenuse is. So what I need to do now is I need to figure out what this missing side is. We're going to go back and do more geometry. We're just going to do Pythagorean theorem. So that's just a squared plus b squared is equal to c squared. A and b are always the legs of your right triangle. So in this case, we don't know this one. I'm probably just going to call it an x. And I know 5. So I've got x squared plus 5 squared is equal to the hypotenuse, or c, which is 13 squared. And then we're just going to do the work. Hopefully this is easy for you guys. Subtract 25. I'm showing all the steps, but I am going kind of fast with this. So pause me if you need to. Square root. Now we're talking about the sides of a triangle, which means I don't need plus or minus this time. I only care about the positive because the length of a triangle, side of a triangle, can't be negative. So this side is 12. If you remember your Pythagorean triples, and I know you guys talked about that a little bit in geometry, you could just write the 12 in there. We are going to use some of those kind of numbers a lot. All right, now it says find the other 5. I always just like to write all 6 of them. You'll see on Buzz, you're always going to kind of have them all anyway. So we're going to have sine, cosine, and tangent. So let's do those first, and then we'll do the, after we finish this, we'll do those other 3 and find the reciprocals. So sine is opposite over hypotenuse, which they gave us. It's 5 over 13. Cosine is adjacent over hypotenuse, so that's 12 over 13. And then tangent is the opposite over the adjacent, and that's 5 over 12. So now what I'm going to do is I'm going to go through and I'm going to do the secant, cosecant, cotangent. So, see if you can try to figure out what matches up. So cotangent is a reciprocal of tangent. Remember I said this was the one that starts with an S and ends with a C? That's a secant. It's a reciprocal of cosine. And so then this one's cosecant. Oops, I probably should have moved over. All right. Watch, all I'm going to do is take this fraction and flip it. Done. Take this fraction and flip it. So if you can get sine, cosine, and tangent, you can very, very easily get secant, cosecant, cotangent. 12 over 5. We're done. That's the answer. All right, let's try another one. So this time, we're going to start by giving you cotangent. Okay, maybe you don't like that. I wouldn't. I'm automatically going to go to the reciprocal, which is tangent of theta. So if cotangent is 3 over 1, I'm just going to flip that and get 1/3. So I'm going to make a triangle, a right triangle here. I'm going to put my theta down here in this bottom angle here. Tangent means opposite over adjacent. So from this angle, the opposite side is right here, and the adjacent side is right here. So I didn't label them this time. Just be really careful where you put stuff. We don't know the hypotenuse. We don't know C this time. So we're going to have to do Pythagorean theorem again to find that. So I'm going to do a squared plus b squared is equal to c squared. A and b are my legs here. So it doesn't really matter what order you do those in. 1 squared plus 3 squared equals c squared. 1 plus 9 is 10. So I don't get such a nice c value this time. It's radical 10, not plus or minus. It's just radical 10. If it helps you to label these sides, go ahead, that's the opposite, that's the adjacent, that's the hypotenuse. So now we're going to do I'm going to do all 6 trig functions. So I might have to scroll up and down. Let me move this. So I'm going to start with sine, cosine, tangent. So we can fit all this. So I've got the sine, the cosine, and the tangent. Let's just start with those. Sine is opposite over hypotenuse. So I've got 1 over radical 10. We cannot leave it like that. We can't leave a radical in the denominator, so multiply the numerator and denominator, top and bottom, by 10. So the sine is technically radical 10 over, if I multiply those together, I just get 10. Cosine is adjacent over hypotenuse. Again, we get another radical in the denominator that we have to rationalize. So we get 3 radical 10 over 10. And then finally, we already had tangent, but we can just double check. It's opposite over adjacent, 1 over 3. So now what I need to do is I need to go back and I need to do my cosecant, secant, cotangent. So tangent matches up with cotangent. Actually, I already had that one. I'm just going to fill that in. If I flip 1 over 3, it's 3 over 1. This one is going to start with an S and with a C, it's secant. And so this one is cosecant. Whatever you guys can do to help you remember those. All right, now if I flip this, I don't have a lot of room right there, so let me just show you down here. If I flip this answer and I do 10 over 3 radical 10, do you see how it automatically puts a radical in the bottom? And then what I'd have to do is multiply numerator and denominator by radical 10 again, and I get 10 radical 10 over 3 times 10, and then cross them out. It's kind of a pain. What I think is easier, if you already have this original answer that wasn't in like a nice format, if I flip that, I've got radical 10 over 3, which is what you would have gotten here too. So if you don't mind doing extra work, go for it. I would much rather just do less work if possible. So radical 10 over 1 is really just going to be radical 10. So there's my 6 trig functions. Got a couple more problems to try here that again should be kind of like review. All right, so now we're going to move on to special right triangles, and you guys did these in geometry. We're going to use these a lot in here. So this is going to be something that hopefully by the end you guys are really, really good at, and if not, you're going to have to be good at it next year for trig. So I'm just going to jot down this SOHCAHTOA there again. This triangle right here is actually a 30, 60, 90 triangle. So I'm going to put a 30 up there. I'm going to kind of color code these. I'll put that in blue. I'll put 60 down here in pink. Now, when you guys learn these in geometry, I'm just going to put this here. Depending on who your teacher was, sometimes there's a little bit of different methods to learning these. Here's my 30-degree angle. Here's my 60-degree angle. This side is the short side. That's x. The hypotenuse is twice as big, so that's 2x, and then the long side is x times radical 3. Some people have little tricks where they'll put like a 1, 2, 3 in here, so like that. This is twice as big, there's a 3 here, so then like if you go from x to there, you multiply or divide by radical 3, since that's a 3. If you go back and forth from here to here, you multiply or divide by 2. All those rules still apply, but what we're going to fill in the box here is really going to be important for the rest of this chapter, unit, whatever you want to call it. So, all right, so let's just take a look here. So I've got some numbers on here. I've got a 1, a 2, and a radical 3. These are going to be very similar. See they come from this here, just fill out the x's. Very similar to what we're going to be using throughout the chapter. Sine is opposite over hypotenuse, and we're doing the 30s right here. So if I'm looking at 30, the side that's opposite is 1, the hypotenuse is 2, so this would just be 1 over 2. Cosine of 30 is the adjacent side over the hypotenuse. Adjacent over hypotenuse is radical 3 over 2. Tangent is opposite over adjacent, so if I look here, I've got the opposite side, which is a 1, and the adjacent side, which is a radical 3, which obviously I can't leave like that, so I'm going to multiply the numerator and denominator by radical 3. So I end up with tangent of 30 is radical 3 over 3. You guys are going to see these numbers a ton this chapter, okay? Maybe not for a few days, but you will see that a lot. So let's take a look at the sine of 60. So now I'm moving on and I'm looking at this angle. So again, sine is still opposite over hypotenuse. So the opposite side is a radical 3. The hypotenuse is 2. So this is radical 3 over 2. The cosine of 60 is adjacent over hypotenuse. So adjacent over hypotenuse. So that would be 1 over 2. And then tangent is opposite over adjacent. So the opposite side is radical 3 this time. The adjacent side is 1, which is just radical 3. I don't have to rationalize that 1. So again, you're going to see these numbers a lot. You're going to see these numbers too with these 45. So let's go ahead and take a look at those. All right, so now let's take a look at this other triangle here. Notice that these two sides, these legs are the same. So when that happens, that gives us a 45, 45, 90 triangle. So both of these angles are 45. Remember, three angles always add up to 180, so that's kind of where these numbers all come from. 90, 45, 45, 180. 30 plus 60 plus 90 adds up to 180. All right, we're going to go through and do the same kind of thing here. If you want to try to remember what you did back in geometry when you did these kind of triangles, if it was, these are always the same when it's 45. And then, so this would be an x, and this would be an x, and then this is x times radical 2. All right, so that's where my numbers 1, 1, and radical 2 are coming from. Sine is still opposite over hypotenuse. So if I take a look, I can look at either one of these. I'm going to refer to this one right here. Opposite is 1, hypotenuse is radical 2. So I've got 1 over radical 2, which I can't leave like that. So I'm going to multiply the numerator and denominator by radical 2 to give me radical 2 over 2. All right, cosine's adjacent over hypotenuse. So if I take a look here, my adjacent side is 1, the hypotenuse is 2. We're going to get the exact same thing we just did. So multiply by radical 2, and I get another radical 2 over 2. Finally, tangent's opposite over adjacent, so the opposite side is 1. The adjacent side is 1, so that's 1 over 1, which is just a 1. All right, we have 2 examples to do, and then we're going to be done with this. But so if we look here, we've got a 30-degree angle right here. We've got x, which is our adjacent side, so I'm just going to label it with an A. And then we've got 8, which is the hypotenuse. So we're looking for this value of x. I could use a special right triangle formula, or just the rules that I had here, and I'll show you that too, but I really want us to start to kind of get used to referring back to this. So I want to show you that also. So what we're going to do is we're going to look here. We've got this angle is 30. We've got the adjacent and the hypotenuse. Adjacent and hypotenuse is cosine. So I've got cosine of angle 30 equals the adjacent side, which is x, over the hypotenuse, which is 8. All right, I'm trying to solve for x, so I need to get rid of that 8. I'm going to multiply both sides by 8 to get rid of it. So that's gone now. I've got 8 times the cosine of 30 is equal to x. Cosine 30, if I look up here at this chart, is radical 3 over 2. So I've got 8 times radical 3 over 2 is equal to x. If I multiply this, I get 8 radical 3 over 2, which 8 over 2 becomes 4, so x is 4 radical 3. All right, so that's the trigonometry way to solve that. Let me show you, or we could do this using our special right triangle rules, which works. We're going to try to avoid that a little bit here, but so if I were looking at this same right triangle here, here's my 30 up there. I've got x and I've got an 8. So if that's the 30, that means that this is the 60. The 60 is twice as big. There's that 1, 2, 3. That's how you do that. To get to this short side, it's half of 8, so I need to divide by 2. That becomes a 4. To get from the 4 to the long side, I would multiply by radical 3, so that gives me 4 radical 3, which is the exact same thing I got using this trigonometry. But this is what we're really going to be focusing on. All right, let's try one with a 45. Here's the angle we're looking at. This is the opposite side. This is the hypotenuse. Sine uses opposite and hypotenuse. So I'm going to do the sine of 45 equals the opposite side, which is x, over the hypotenuse, which is 5. Solving for x, so I'm going to multiply both sides by 5. I've got 5 times sine 45 is equal to x. Look at our chart here. And the sine of 45 was this radical 2 over 2. So that's what I'm going to use right here for sine 45. 5 times radical 2 over 2 is equal to x. If I multiply, that's really 5 over 1. So 5 times radical 2 is 5 radical 2. 1 times 2 is 2. That's what x is equal to. If I was using my special right triangles with the 45s, I had a 5 here, I had a 45 here, which means that's a 45. This is the x. These are the same. So I would multiply a leg times radical 2 to get to the hypotenuse, or I could divide by radical 2 to get to the hypotenuse, or to get to the leg from the hypotenuse. So if I did 5 divided by radical 2, you can't leave it like that. So I'd multiply by radical 2, and that would give me 5 radical 2 over 2. Same answer. This is how you would have done this in geometry. This is what we're going to try to focus on in Papa 2. All right. If you guys have questions, let us know. Have a good day.